Hello everyone, this is Jason. We're looking at how to find domain and range from a function. So I'm going to give you three functions similar to the ones you see in your lesson. We'll talk about how to find the domain and range. So if we look at this first function here, remember domain, just remember domain is a list of all the x values. It's a list. Range is a list of all the y values. So when you write these, you're going to have to take every single one into account when you write it. It's not just going to be some single numbers. You're going to have to write them all. The only times it's single numbers is if you're just given a finite list of values that make up the function. So let's take a look at these. You're asked to use Desmos to include a graph. I would actually draw the graph first. That way it'll help you kind of identify what the domain and range are. So here's the first function. I've got y equals x to the sixth and plus 3. So there's my function. So there's the graph. Now remember that the domain lists all the possible x values. Well, here's a trick for domain. Unless you see special functions, like y equals something over x, where x is a variable, where you see square roots, where you see logs, which, we'll talk about all those eventually in this course. Those are the ones that's going to be limiting factors. So if I don't see anything limiting like that, like a denominator, a root, or a log, or some kind of special function, typically the domain is all real numbers. So in this case, the domain is all real numbers. And we can write that as negative infinity to infinity. And how can I look at the graph and tell that? Well, if there's no jumps, skips, or anything like that in the graph, if it's continuous, if I can put a point here and I can keep going without having some sort of a change as far as a hole in the graph where it's saying something that's an error, then it's going to be a good graph. If I zoom out and I continually see lines keep going forever, which I will, that means that the domain will be all real numbers. Okay, so let's take a look at the range. Get that back centered a little bit there. I'm just using my mouse to scroll down here. All right, so the range. Ranges can be limited more than domains usually. Ranges will be where the graph curves, like here. I'm going, I'm down, 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 down. And then all of a sudden I make a turn and I head up. So that means that where that turn happens and it goes the opposite direction, so it's going down and now it's going up, that's going to be the limiting factor. Now for parabolas, this is basically a parabola, it's going to be where the vertex is. So you can find the vertex, you can find the limiting spot. So on Desmos, I'm looking right here, that's my low point, 0, 3. So that means 3 is going to be the limit to my y values. I can't have a value lower than 3, and you can see that in the graph. So my range is going to be all y values that are greater than or equal to 3. And I can write that as in this formation with a closed bracket. Closed bracket means that the endpoint's included to infinity. And infinity's always got a closed or parenthesis because it's an idea, not an actual number. All right, so that's domain and range. That's really all you have to do. So let's look at a couple other examples. Let's look at this example. This is similar to one in yours as well. So I'm going to just type that in. We got 3x to the 5th plus 4. And if we look at this graph, again, first thing I want to look at is domain. Are there any places where it's going to have a jump, skip, turn in the graph? And I say turn, but I skip where there's nothing. And I'll show you an example after I do this one. So this one has nothing special. Again, I can kind of look at this and notice that it doesn't have a denominator for an exponent. It doesn't have a square root. It doesn't have a log. It doesn't have any of those. So I know based on that this domain for this so I can see the domain for this, again, is going to be all real numbers. And again, we write that as negative infinity to infinity. Now, what about the range? So let's take a look at this. Get rid of this. Let's take a look at this. If I look at my curve again, are there any limits to the y this time? Well, I don't see any place where it doesn't keep going continuously in either direction. So guess what? The range is also all real numbers. And so again, that's negative infinity to infinity. Okay, so real simple. And let's look at one final example. This is a root. Roots, even roots are going to have some limitations. Odd roots, not so much, because you can take a root of an odd, believe it or not. But and let me show you one thing before we get to this one. So let's suppose I had y equals 1 divided by x. You see where I have this jump in the graph where I'm continuous here, and then all of a sudden I go the opposite direction, but I can't get to this without making a jump to go over to this one. So that's what I mean by a jump in the graph. So if you see something like that, you're definitely going to have some limitations. But let's get back to this one. So this is our final example here. We've got y equals 2. And now to do roots in Desmos, you have to be real careful. You notice I'm putting it in parentheses. And my root will be a fraction of the index. So my index is 4. So that means my root is to the 1/4 power. So my index is 4. My power is 1/4. If my index is 2, my power is 1/2. If it's 3, 1/3. So that's all based on that index right there. All right, so this is that. And then I'm going to raise it to the 1/4 power. And you see there's my curve comes up, and you notice there's some limitations, just like it has limitations for x and y. So I find that endpoint right there, and I notice that there's no x values to the left of that. So that means 1.25 is my limiting x value. So that means my domain would be all values of x that are greater than or equal to 1.25. And how would I find that without a calculator? I would set what's in the radical equal to 0, solve it, and you'll get the same thing. So now I can write this as an inequality, or I can write it as 1.25 to infinity. And that should be our closed bracket right there, because it's included. Now what about the range? Range, same thing. It doesn't look like there's any values in this graph below 0. So nothing below 0 will be included as a possible y value. So I have to indicate that by saying that y would have to be greater than or equal to 0 or 0 to infinity. So I hope this helps you with domain and range. It's not don't make it any more difficult than this. It's real simple. Look at the graph and let the graph kind of tell you what to do. But if you still need help, please let me know, and I'll get you some additional resources.